In this video, we're going to be discussing mean as the balance point. And we've talked about it before. The mean of the number shown on a number line or other visual is also called the balance point. So for example, what is the mean of this data? So what we need to do is you have to pull off the values from the number line. So we have 0, 0, 0, 1, 1, 1, 2, 3, 5, 5, and then 6 and 6. To find the mean, you're going to add all of those together. When you add all of these numbers together, you get 30. And then you're going to divide by how many there are. Remember, add, divide. That's how you find the mean. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're going to divide by 12. And 30 divided by 12 is 2.5. So it's not a perfect answer. It is a decimal, but that's okay. Means can be decimals. So you go ahead and you do the next one right here, the one that says try on your own. So pull the numbers off of the number line like we did here, and I want you to find the mean. So when you pull the numbers off, you have 0, 0, 0, 1, 1, 1, because we have 3 ones, and then a 5, and then a 6. If you add those together, you should have got 14. Then you're going to divide by how many there are. There's 1, 2, 3, 4, 5, 6, 7, 8, and you get 1.75 for your mean. Now, that's how you find the mean when you know all the numbers on the number line. Sometimes you're not going to know that. So the balance point can be defined as the point on the number line where the data distribution is equal. So I know that you guys in elementary school have seen a scale that kind of looks like this. And then you can put weights on it. So maybe a square is equal to a circle. And they're the same weight. And you want to make it so the teeter-totter is equal on both sides. And just like if you were to have people on here, if you have a person over here and a person over here and they're the same weight, they're going to make both sides of the teeter-totter stay off the ground. Whereas if this person's really heavy, the teeter-totter is going to be more like this. Oops. And the circle would be in the air if the square was heavier than the circle. Now, we want this to be equal when we're doing the teeter-totter. So, just like with the shapes or your weight, think back to when we did equations. We wanted both sides of the equation to be equal. So 3 to equal 3 when we did our check step. So that's something that we're going to pull back in doing this next problem. So show why, which shows why the balance point of the following data set is 4. Okay, so the first thing we're going to do is we're going to put these numbers on our number line. So we have a 7, we have a 3, we have a 5, a 1, a 2, and a 6. Okay, now you can kind of start to visualize what the balance point is going to be. Where do these all balance if this number line was a scale? Well, you can kind of see that they're all equally spaced around the 4. So the 4 is actually going to become the fulcrum for that balance point. So what you're going to do is I want you to draw a line on 4. And it actually says shows why the balance point of the data set is 4. So that's why everything's all kind of around 4. And I want you to write the word mean here because this is the balance point. And the balance point means that they're equal to each other. So the fulcrum is there from our scale. That means the mean, and then we have an equal sign. Now, how can we prove that 4 is the mean or the balance point of this data on the scale? Well, we're going to count how far each x is away from the mean. or the balance point, which is 4. So the 3, and really you don't even need to pay attention to the 3. The number, we're just looking for the space. The 3 is 1 space away, so we're going to put a 1. The 2 is 2 spaces away, and the 1 is 1, 2, 3 spaces away. We're going to add those together to figure out what's the total weight on this first side. So if we add these together, the weight on this side is 6. We want to make it equal on both sides, just like we did with equations. So the 5 is 1 space away. The 6 is 2 spaces away. And the 7 is 3 spaces away. Add them all together. Find out what the weight is. 1 plus 2 is 3. 3 plus 3 is 6. So 6 is equal to 6. Now, knowing what we've written here, I'm going to come back up into these answer choices now. 1 plus 2 plus 3, 5 plus 6 plus 7. No, that's not what I wrote down here. That's the numbers that are on the number line. I'm actually looking for the distances. Because if you add these together, you'll get 6 on this side, but 5 plus 6 is 11, and 11 plus 7 is 19? No, that's not right. 18. And 6 is not equal to 18. Same thing if you look at this one here. 7 plus 3 plus 5 is 15. And then 1 plus 2 is 3 plus 6 is 9. 15 is not equal to 9. 1 plus 2 plus 3 is 6 is equal to 6. So that's why C works. And 3 plus 1 is 4 plus 6 is 10. And 7 plus 5 is 12 plus 2 more gives you 14. 10 is not equal to 14. So you have to figure out where are they actually balanced. And over here, our distance, I ended up just writing it underneath. The distance on the left from 1 is 3, from 2 is 2, from 3 is 1. And if you add those all together, you get 6. And then from 5 is 1, from 6 is 2, from 7 is 3. And if you add those together, you get 6. So they're equal to each other. Okay, so let's actually do some hands-on math. So what you need to do is you need to put your binder off to the side. You need to get a dry erase marker and make a number line from 1 to 10. And you need to get some little paper circles from your teacher, and you're going to use those as markers where the little red blocks are. You need to use the paper. You cannot use just your marker to draw the blocks. So gather those materials if you need to get them. So what you're going to do is we're actually going to practice moving these pieces to find the balance point. So what I want for you to do, now that it's all set up and it's on your desk, I want you to put your finger on this one here and so that's your left hand, and put a finger from your right hand on the 9. So you should have both your fingers on your pieces. One finger should be on the 1 on your left hand, the 1 should be on your right hand with the 9. Now at the same time, I want you to move the 1 in one space with your left hand and the 9 in one space onto the 8 with your right hand. So now they're moved in. And we're going to continue to move these in order to find where they're going to balance at. And eventually they'll all stack up into one spot. And you always want to start on the outside. So now you need to remove your hands. Put your left hand or finger, left hand, one finger on the 2, and put your right-handed one finger on the top of where that 8 is, on the top one, the first one. And then you're going to move the 2 to the 3 and the 8 to the 7. Remove your hands. Now do it again. This time I'm going to start with the top 3. with my left and the 8 with my right. Move it in 1, move it in 1. Remove your hands. Put your finger on the outermost 3, the top 7. Move it in 1, move it in 1. Remove your hands. Start again. Top 4, out 7. Move it in 1, move it in 1. Now at this point you probably be able to estimate where you think they're going to stack up because they're kind of even on both sides, so they're probably going to stack up in the 5, but I want you to practice it very quickly. Move it in 1, move it in 1, remove your hands. And then the last one, put your finger on the 4, finger on the 6, move it in 1, and move it in 1. So our mean or our balance point for these pieces was 5. Okay, so let's try another one. So draw a number line from 1 to 10, place your little circles on the number line. And you're going to take your fingers, one on the left, one on the right, then move your pieces with your fingers in one space. And then remove your hands. The outermost one, put your finger on it. Outermost one, put your finger on it. Move it in 1. Move it in 1. Remove your hands. Oops. And continue this. They're going to continue to move. 1, 1, 1, 1. Across your paper, or I guess it's your desk. 1, 1. Left, right, left, Make sure you're pulling always from the outside. And now we can start to see that our balance point is going to become on the 4. All right, so what I want you to do is I want you to set this one up on your own. I want you to move in the pieces and I want you to find the balance point on your own. So outermost, move only one space. One space. One space. Outermost, one space. Outermost, one space. Outermost, one space. Keep going. And now we're starting to see what the pattern is, and the mean is 5 for this one. So if you got it to 5, good job. Set up this one and try this one on your own. So moving your outermost pieces one at a time. Pulling always from the outside. And you can start to see a pattern happening. They're forming on top of 7. So the 7 is the mean for this one. Now, how does this apply to what it looks like on paper? So show why the balance point of the following data set is 5. So what I want you to do is I want you to set this up, and I want you to prove to me, draw the line, your equal sign on 5, that's your balance point. We're going to set it all up. And then you have to draw 8 on here because it's not long enough. And prove to me, show me some math underneath, prove to me why the mean is 5. So go ahead and try that. So if you look at this one, 1 is 1, 2, 3, 4 spaces away. And so is the second one. It is 1, 2, 3, 4 spaces away. So I'm going to add those two together. 4 plus 4 is 8. 6 is 1 space away. 7 is 2 spaces away. So is the second 7. It's also 2. And then 8 is 1, 2, 3 spaces away. 1 plus 2 is 3, plus 2 is 5, plus 3 more is 8. So that is why, right here, the balance point is 5. Now, here's where it starts to get a little bit tricky. If 4 is the balance point, so here is our balance point, where should we add extra x's? So, first thing that we need to do is we need to figure out what math do we have going on here. So 3 is 1 space away from our balance point. 5 is 1 space away, and 6 is 2 spaces away. So if we do the balancing here, this equals 3. This is only equal to 1. So what do I need to add to 1 to get to 3? Well, I need to add 2 spaces. So start from your balance point and go out 2 to this side, because this is where I need to add more weight. 1, 2. So I'm going to add 2 spaces, which turns out actually to be the number 2. So I'm going to put an X on 2 to make this balance with 3. So put an X on 2. Let's try another one. Place the following numbers on the number line. If 2 is the balance point, where should I add another x? Now, there's not a lot of space above this one, so I'm actually going to put the x's below. So we have a 0, 2 1s, a 4, and a 5. And they want the balance point to be 2. So let's do some math. The 1 is 1 space away. This one is 1 space away, and the 0 is 2 spaces away from the balance point. 4 is 2 spaces away from the balance point, and 5 is 1, 2, 3 spaces away from the balance point. Doing some math, 2 plus 1 is 3 plus 1 is 4. 2 plus 3 is 5. So if we look at this, this is unbalanced. I need to add another x. Well, 4 is where I can add some to make it balanced. How many do I need to add to 4 to get to 5? Well, I'm going to add 1. So start at your balance point and go out 1 space, and it actually turns out that it's at the number 1. So I'm going to put my x on 1 to gain some weight on this side. So I add 1 to get 5 equals 5. Okay, so you try the last one on your own. So if we set this up, we need to add 2 more x's in this one, and I want the balance point to be 3, so that's where I want it to equal. 2 is 1 space away, 1 is 2 spaces away, and there's 2 of them, and 0 is 3 spaces away, and there's 3 of them. 7 is 1, 2, 3, 4 spaces away. If I add all of this up, it actually comes out to be 14 on this side equals 4. So I need to add 10 spaces, but I need to add 2 x's. So if I add 10, that'd be 1, 2, 3, 4. If I add 1 here. And actually, I should have told you this. You need to extend your number line because they don't quite fit. Because that's 4 spaces, so 4 plus 4 is 8. but I still need to add 6 more. So 1, 2, 3, 4, 5, 6. So I have to add an x to 7 and an x to 9 in order to make it work. I apologize if you had trouble with that one.